Hello everyone! Today I'm going to explain the working principle of the electrical cabinet in the cabin. Next, let's delve into the yaw electrical system section together. Modern megawatt-level wind turbine generators are mostly devices that operate automatically around the clock. The entire operation process is under strict control, so the electronic control system is also of vital importance. First, let's take a look at the composition of the electrical system. For direct drive wind turbine generator, they generally consist of four major parts: wind turbine assembly, nacelle assembly, tower assembly, and power generation system assembly. Further refinement is as shown in the following figure. In the impeller assembly, there are blades, heads, pitch systems, etc. In the generator section, there are electronic components, rotors, braking systems, etc. The cabin assembly includes yaw systems, electrical cabinets, weather stations, etc. In the tower assembly, there are ladders, towers, frequency converters, etc. Then it can be seen that the electrical components of the wind turbine generator are distributed in all parts of the unit. In terms of location, they are mainly located in three places: the engine room, the bottom of the tower, and the wheel hub. The overall structure of the cabin is presented here. Specifically, there is a wind measurement system and a nameplate on the outside of the cabin hood. The yaw brake disc, yaw bearing, yaw reducer, yaw motor counter, and electronic control system are arranged on the chassis inside the cabin hood, as can be seen from the following picture. The electrical system of the unit includes the tower crane control cabinet, the nacelle electrical cabinet, the hub control cabinet, the frequency converter, the transformer, the remote monitoring system, and other components such as wires and cables. So how does the system operate? Let's look at the next picture. On the left is the remote control part of the unit. One is the operation and monitoring system, and the other is the control system. The operation data of the entire system can be viewed from the computer interface, thereby controlling the pitch system, yaw system, and power generation system. The picture on the right shows a combined cabinet that simulates the base cabinet and nacelle cabinet of the generator set. The main components of a wind turbine generator are generally located inside the nacelle. In order to control and detect these components, generally, an electrical cabinet is set up in the cabin, which is equipped with a built-in PLC and various switches. And the information is transmitted to the bottom of the tower through industrial bus communication. At present, most wind turbine generators generally adopt PC as the core component of the main control. PLC, or Programmable Logic Controller, is a widely used component in today's industrial control. The cabin electrical cabinet mainly includes CPU and memory, power module, I/O module, dedicated communication module, and dedicated functional module, etc. Contactors, circuit breakers, fuses, lightning arresters, relays, power modules used to control the actuating mechanisms of wind turbine generators, as well as common distribution equipment in various places. They are generally installed centrally in electrical cabinets. It can be seen from this circuit breaker layout diagram. From top to bottom, they are the switch section, the PEC section, the driver module, and the data communication module. Now that we know the structure, let's take a look at the working principle. Take a 1,500 kilowatt permanent magnet direct drive wind turbine generator as an example. Its electronic control system includes the main control system, permeating system, and pitch system. The unit control system in the figure consists of a low-voltage electrical cabinet, a capacitor cabinet, a control cabinet, a converter cabinet, an engine room control cabinet, 3 sets of pitch control cabinet, sensors and connecting cables, etc. The main control system is mainly responsible for 3 functions: normal operation monitoring, operation status monitoring, and safety protection. The converter control system adopts the AC-DC King conversion mode. The low-frequency alternating current generated by the generator is rectified and converted into pulsating direct current. The output is a stable DC voltage after chopping and voltage boosting. It is then converted into alternating current of the same frequency and frequency as the power grid through a DC-AC inverter. Finally, it is connected to the power grid through a transformer. Complete the task of transmitting electrical energy to the power grid. The converter system of the 1,500 kilowatt permanent magnet direct drive wind turbine generator is a full power converter device. It has good compatibility with various power grids. It has a wider range of reactive power regulation capability and the ability to support grid voltage. As can be seen from the following figure, the yaw electrical system includes a weather station, yaw motor, module, junction box, and yaw bearing, grease pump, module, etc. The above is the learning content of this class. Thank you all.